All right, so in this problem, example 2 and 4.6, we are just going to learn how to add and subtract complex numbers, and we're going to also look at later on multiplying and dividing. So as a review, in example 1, we talked about situations where these values, these complex numbers with imaginary numbers, these I values, come into play. We showed that to you right from the start. If you solve a problem and you happen to get a square root of -4, then we, at the very least, are aware that this is a different type of number altogether than what we've seen, and we can reduce this, in this case, as like 2 times I. We make these substitutions to make it easy to read and understand, hey, this is an imaginary number. But now in example 2, we're just going to go back and talk about what we call these complex numbers. Complex numbers are of the form a plus bi, where if it's an imaginary number, right, we have this a value, which is just a regular number, which is just a real number. That's called the real part. And then the b times I is, of course, going to be the imaginary part of the number. So this is the standard form of what we call these complex numbers, specifically numbers that have imaginary or these I parts to it. So these next 2 examples are actually going to be pretty easy. It's just the terminology that I start with that seems a little difficult. But in example 2, all we're saying is, how do we add complex numbers? This is a new number system for us. So how do we add these numbers? So I have one complex number here, and then plus another complex number. How do I add those numbers? All you're going to do is just combine. There's really nothing new or fancy here. You're going to combine the like terms, and that's it. It's actually really easy. So we're going to take the real number portions, the 12 plus -8. We're going to combine those because those are like terms. So that's 4. And then I'm also going to take the imaginary portions, right? I got -11i plus 3i. Well, that's going to give me -8i. And so there's my answer, and I'm going to leave it like that. So remember, this is the form of a complex number. And if I'm going to add these 2 complex numbers, I'm just going to add the like terms. Really, really simple. Okay, next one, what if we subtract? Right? Well, if we subtract, nothing really changes besides that we have an I in there. So if I subtract these things, I'm going to take 15, the real number portion, minus 24. And so if I do that, I'm going to get -9 for the real number portion. And then if I look at the imaginary number, I would have -9 minus -9. Well, that would be like -9 plus -9. So there basically is no imaginary part in this problem. We have 0i. So we don't really need to write that 0i there. This just becomes a -9. So important to realize here that I can actually have 2 imaginary numbers, but when I add them together, that imaginary number just goes away, and I'm just left with this real number now, just -9, what we're used to. So that type of thing can happen. All right, so we learned how to just add complex numbers together. What happens when we multiply complex numbers together? So here's an example of multiplication. And again, when we multiply complex numbers, there is no new method. There's nothing different. We're going to multiply as we normally would multiply. So this first example, we're going to take this -5i, and we're going to multiply and distribute these terms inside. We're also going to use our exponent properties when we need to. So if I have -5i times 8, I know that I'm going to have -40i. And then I have -5i times -9i. Well, that would become plus 45i squared. Now here's one thing that you just need to know when you're multiplying, or just from the definition of what we call I, right? All we're saying is that this I term is equal to the square root of -1. Now naturally that means that if I were to square both sides of that equation, that has to mean that I squared would have to be equal to -1. So we already made this substitution, but because we made that substitution, it also is the case that if I have an I squared term in the problem, that has to equal just normal -1. And so this is the thing that you have to remember, especially when multiplying things together, that I squared is equal to -1. So going back to this problem right here, this I squared, because that popped up in the problem after multiplication, that is equal to -1. So this problem is actually -40i plus 45 times -1, which is this is -45 right here, right? So, so my answer is -40i plus -45, and so I basically have a complex number there. Remember, a complex number is a plus bi. Well, if I just write this and I switch these terms around, then I'm going to have -45, my real number part, and then I'll have a plus and then -40i here. There's my answer. Okay, so I take one complex number and I multiply it by another complex number, and I just basically multiply everything together, just like what we did in chapter 5 and then a couple sections ago. Just multiply the things together, but understand that I squared is equal to -1. All right, so let's try the next one. So I have, again, another complex number times another one. And I'm going to multiply this together. I'm going to do this by distributing. I have to multiply 4 things together. So if we go ahead and do this, I'm going to have -8 times 4, so -32, and then -8 times -7i, so this is plus 56i, and then I'm going to multiply 2i times 4, which is 8i, and then 2i times -7i, which would be -14, but I squared. Okay, so we go ahead and multiply. We're going to combine our like terms. So I know that, there's 2 things here. I'm going to combine these like terms because I have 56 and 8i. That's going to become, 64i. So this becomes 64i. I have a -32 here that's just going to bring down, but this -14i squared, well, we have to remember that this I squared is equal to -1 right here. That's equal to -1. So therefore, I have -14 times -1 there. Well, that would become just plus 14. All right, so then we can keep on going here and say, all right, well, then I can combine this -32 and that 14, and so this becomes -18, and then I still have the plus 64i. So this is how that multiplication would come out. All right, I'm taking one complex number times another complex number, and the result is a complex number, which is a plus bi. Got to remember that we set this whole system up by saying I is equal to √1, but that means that I squared has to be -1 then, and we use that to our advantage. All right, so here's a couple practice problems. Go ahead and pause it and try these. All right, so for the answer for A would give me 3. I'd take these 2 things and just add up the like terms, so I'd have 3 and then -4i is an answer. And then D, I would distribute, so I'm going to get -8 -32i -2i and -8i squared. And then this would become -34i. This right here is going to be plus 8, because that's -8 times -1, which is positive 8. So I'd have negative 8 plus positive 8, and I would basically have 0 plus or minus negative 34i. So that is it for that problem, just negative 34i.